Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 171. Minimum inversion count in subarrays of fixed length. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. Honestly, I didn't think this one was super difficult. I did in less than 5 minutes actually. And I even had a minor typo that made it slower, so I probably could have done it a little bit faster. I mean, the reason is because there is already a lot of literature on inversions, and this idea, this properly, there are a couple of ways you can do it, but for this one, we want something that's progressive, right? And the thing is that the subarray of length k already, for me anyway, just to give you a little bit of my thought process, is that saying this length k thing means that, okay, well, we have this thing, right? We're taking a length k, and then we're also doing 1 over, 1 over, 1 over, 1 over, right? And as a result, it seems like a very natural sliding window kind of thing, right? Because everything's length k of subarray. So then after that, and knowing my inversion history, it just becomes, well, okay, well then now what ideas can I have for inversions that allows me to kind of add a number and also subtract a number, but also from those numbers maintain the inversion count as we add and remove things as part of the sliding window. I think if you don't know inversion stuff, definitely practice on the easier problems. There's a divide and conquer solution. There's also I use sorted list, but there's also a binary search tree idea that you should play around with and practice with. And I will also say that once you do that on the easier problem, this becomes kind of trivial. Of course, there is an n square solution for inversion counting as well. That is basically trivial, and of course doesn't work for this one because n is 10 to the 5th. What I mean is n log n based solutions. The most famous, the textbook one is, I think, divide and conquer, but that one doesn't help you here with respect to, yeah. And for me, like I said, the idea is just a sorted list. The idea is actually kind of simple, so simple that I don't know how to kind of explain it. Let me know in the comments. But the idea here is that, well, you have a list that's sorted, and the invariant is that it's sorted. If you binary search for a number, well, then now you know how many numbers are currently for a window smaller than it and bigger than it. And once you know those two things, everything just kind of, I mean, that's all you need, really. That's literally an inversion count. Because then now you could do it incrementally. And then maybe even decrementally? I don't know. But sliding windowly, right? A lot of adverbs. But yeah. And we'll go over my code. I mean, it's like it's barely that long. So yeah, I did infinity. Just for the best. Oh, and we're trying to find a minimum here. So you have to be careful, but yeah. So current contains the current inversion count of the window, right? So here we set it up. When we add a number, well, R is going to be the number of numbers that are on. Well, R is technically the index when you get a bisect right, which means the first index in which the number is or the value of that index is strictly greater than x, right? So we get this. So then the number of numbers that has that property is just n minus r. And this is not n, this is the length of the current sorted list, right? So maybe I'm mixing things up by saying n, but it's just the length of the current list because in the beginning it gets, if you start with 1, 2, 3, and then it gets to k, right? And then it becomes k. So you have to be a little bit careful. I don't know. And then, yeah, so this is the actual count. And this is, remember, this is the count of the numbers that are bigger than the number that you're inserting. Why? Because that means that, because the numbers that are in the window are numbers that are to the left, right? Or the prior numbers. That means that if you have a smaller number than them, then it creates inversion, just by definition, right? So or actually, well, yeah. If your current number is smaller than previous numbers, that creates inversion. So that's why you're searching for the count of the bigger numbers. And then kind of the same thing, but also in reverse for the left side, right? So you add a number to kind of extend the window, and then you subtract a number to shrink the window, and well, what's the inversion count? Delta is just the number of numbers that are strictly smaller than this number, and so you use bisect left. And yeah, and then you just remove it with Gucci. And then at the end, if the window size is at least, or in this case, actually it should be exact, it's exactly K, you update the best to see if the current inversion count is the best. And that's it. Yeah, so what's the complexity here, right? Well, we have an O of N loop. We have 2 binary searches, up to 2, I suppose. And 2 log N add and removal. So this is just going to be a symbol N log N. Yeah, that's it really. Like I said, if you have comments, you can leave it there. But if you want to get, if you have questions, specific questions, let me know in the comments as well. It's easier to answer questions than just to guess what you're trying to ask. But yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve it live in the contest now. Yeah. I don't know why I did it with the DP way. I think I just kind of, I don't know, brain fart. People did it so fast, but I did it in a dumb way. Okay. These times are just not reliable anymore. Okay. What's K? Oh, I see. So we're solving it. So there must be some sliding window E thing. Maybe. So okay, so we do this. Or maybe not sliding window, but well, maybe sliding window. What is N again? N is big, so we have to do divide and conquer in this. And then now, then it's just easy, right? Because it's just removing the 3 and adding the 5. Okay, I mean this is pretty straightforward. We just have to do and we don't even have to do the divide and conquer thing, right? We can just do sorted list type thing, right? So okay, yeah, annoying but doable. Okay, I think everything is annoying to me because I'm just lazy. Okay, so then now we add a number, right? So when we add this number, we count the numbers that are bigger, right? As the inversion. Oh, the minimum inversion count, not the total. It's the same thing though. It doesn't matter. I mean, it's just a different thing. For some reason, I thought it was going to be sum of all subarray inversions or something like that. Which I guess maybe there's a different solution on just counting principles. Okay, but for this, then now, yeah. We want to count the stuff that's strictly greater than. So let's just say this is R, length of SL minus R is going to be the count. Right. So this is the current total number of inversions. So and then SO dot add R, right? Nope, X, right? And then now do 2 things. Just sliding window. So this is greater than 0. Then we subtract it, right? But before we subtract it, now everything that's inside we want to. The number of inversions is the number of numbers that are smaller than it, right? So oops. number of numbers that are smaller than it. Okay. That's it. Actually. And then now if this part, so if I is equal to k minus 1, then now we have exactly k items, and then we just do current, right? So best is equal to min best current. And I think this is it. Nope. Well, I got the 2. Did I mess up? Okay, 1, 2. Why does this only show once? That's probably, oh, I'm dumb. Okay, so that's why this is wrong. That's okay. Alright, 060, alright. We Gucci, let's give it a spin. Should be fast enough, right? Okay, yeah. Not too bad. A little bit sad about the Q3, but thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, these problems, everything in between. Stay good, stay healthy to mental health. I'll see y'all later and take care. Bye bye.